If your vision calls for increasing the scale or scope of Scala-based technology, Micronautics Research, the Scala Enablement Company, can help your organization succeed with Scala projects on time and on budget. We are a software design build firm specializing in Scala, Java, akka, and the rest of the type-safe stack. Micronautics Research offers mentoring, training, software development, and cutting-edge publications. Our clients are all over the world.
So thank you for coming here. Yesterday I did a similar talk. As Mike said, it was at LinkedIn. So I have a lot of things to show, and I would prefer like to show you something that makes sense for you, right? I mean, something that you don't already know about. The problem here is that the level is quite different. There are people that don't know at all about Play, and there are people that really have some experience with Play and they would like to know more about it. And that's very hard to target, right? So I will try to present Play fast, to walk through what Play is, and then I will get into the examples and into what I'm trying to illustrate. The talk was supposed to be about real-time web. I will go through a lot of topics until I get into the main topic, which is real-time web. Okay, and feel free to ask me questions from time to time so that I know like what to focus on and what to pass maybe fast on.
If you have a question, raise your hand. I will come with the mic.
Yeah. Okay. So I am Sadek Aldrobi. I joined the Play framework, Zenexity, and the Play framework. It was at version 1 point something. I worked a bit on it, and then we started writing from scratch the Play 2. I co-created with Guillaume Moore. Guillaume is the founder of the framework, and we worked on Play framework for quite some time until we released the first version. And what's funny is that 1 year ago, just at the release, I remember I was here at Cloud. So when we released Play 2, we released it, and we were here at Cloud. So it's kind of funny to get back a year after and to talk about what happened last year and how did we succeed in doing all what we had to do. And I work at Zenexity, so I would like to present my co-workers. This is on the right. It's well, my right is Guillaume. Guillaume is a founder of the framework, co-creator of Play 2. And there is myself, and there is Habib, who is our CEO. He's a really visionary CEO. He invested a lot in the framework, into us working full-time on that framework until we got it out. So you want to be really courageous to be investing so much money into into an open source project. And we had our own reasons because we use it actually internally in Zenexity. But I would like also to thank him for all his confidence in us. And I work for Zenexity. Zenexity is a company that does web-oriented architectures, which means we have clients, they have applications, they want to migrate them in the web, or they want to solve some architectural problems, and we show them how to solve these kind of architectural problems using the web, using distribution, and so on. All right. So basically, we don't write frameworks. What we do is we write web applications, and the fact that we did Play, it was like we really had a need for a framework that responds to some needs. So basically, what we started doing is like we get what frameworks are there, and we started using them, right? And then we started adding some stuff on top of them, right? Like something like we wanted absolutely to have something like hot reload that I will show afterwards, and some other properties, and it started making sense. And we started like, okay, that makes sense. Let's try to package it in some way. And we did that, and then we started writing some tools around it, and that was Play 1. And it made sense, and then we continued in the architectures, things changed, and we got Play 2. So it really, the way Play framework evolves is out of some need that we had for our own clients. Yes, question?
Have you been involved at all with SBT?
Oh no, we haven't been involved in SBT. That's a different project, completely different project. Okay, so, but we use SBT in Play, which is a different thing. And then we talked with the TypeSafe guys, and we said like, hey, we have this framework that is really cool, and we're doing it on top of Scala, Akka, and all and SBT and all these technologies. And let's maybe do something together. Or what about like having Play into the stack? And that's what we had last year, having Play part of the TypeSafe. We were really looking for this kind of thing. We were looking for this stack, the modern stack where Play could live in. Because, I mean, at that point, and I can say it now confidently, we had a lot of suggestions from a lot of stacks that do exist today, including like most of them, to include Play in that stack. But we were looking for a modern stack that is done for the future, for problems of the future, concurrency, distribution, and these kind of things, right? We didn't want to integrate Play into into the past, but rather into the future. And that's why it made sense. We did the whole thing with TypeSafe together with the NXT. Like we did several projects for TypeSafe, and we are very happy today that Play is part of the TypeSafe, not only part of the TypeSafe stack, but it's also managed by TypeSafe. Which is like Peter is doing a lot of efforts. I should add his photo maybe to my slide. So Peter Hossel is doing a lot of efforts into managing this project and making it really structured, real world, with communication with clients to know what's happening, what should be happening. Okay, enough introduction about the framework. But I just wanted to give you the picture because it's a bit tricky to know. Like sometimes we say Zenexity, sometimes we say TypeSafe. I like to say the true story about why the two companies exist and who's doing what. Okay, now what is Play Framework? Well, Play Framework is a web framework that tries to take advantage of the web, which means we don't try to hide the web, but try to say like there are a lot of good properties of web, so let's try to exploit them. Let's try to take advantage of these kind of properties. But to do that, we need to acknowledge that we are working with the web. We don't need to hide it. We should not hide the web. And that's the first idea of the framework. Question?
Can I just ask a question about the relationship with TypeSafe?
Yeah.
So, are you guys actively involved in Play?
So the question is like regarding the relationship with TypeSafe.
Also, is TypeSafe putting developer resources into the project?
Absolutely, yes. So I still work with Guillaume on the project, on some design issues, some strategic things on the project, but there are a lot of people also at TypeSafe working on Play, and there are more and more resources working on Play development at the TypeSafe side. Okay, and there are two full-time for now, and there are others that will be also joining, so yes. Okay, so first thing, we want to acknowledge that there's a web and take advantage of that fact. Okay. Now, second thing, we want a simple model, right? I mean, we know the Scala programming language is a very interesting language. It has a lot inside it, and what we want it to do is like, okay, we want this kind of progressive learning curve, where you start by doing some simple task, and it should be simple, okay? And then you want a bit more, and then you can add from the Scala power to this kind of to what you're trying to do, and you get more power. So we want it absolutely to have this. And actually even more, we want it to start, okay, you know Java, then you start writing Java. You can use Play completely from Java and then start like having some problems that are a bit more complex, and then you say, okay, now I need a bit of Scala because I got some distribution, parallelism, concurrency, and then I can use these kind of tools, right? And so on. And this was also a very important thing to have in Play. And a lot of other properties in the architecture, which is completely stateless, which is very scalable, very reactive, something I will show more in later on. Okay? And I will explain about this reactive model. All right? So maybe let me start a new Play application and show you how does it look like. Let me kill yeah, okay, we're good here. So when you download Play, I don't know where we're, okay. Let me see. No, not this one. Okay, let's say it's this one. Okay, so when you download Play, So you get, if you download it, it depends when you download TypeSafe or you download the Play framework. But let's talk about going to the Play framework page and downloading the archive, the zip file or whatever it is. And then you unzip it somewhere, and inside this folder you will get a play command. Okay, that's what you will use to start your applications. So imagine I have it. Let's go inside workspace, and then I guess it's inside here, or I can use it here. Okay, let's see what's got. Okay, just let me remove this one. Okay, so what I'm going to do is call play. So it's not here. Where was it? Just a second. I'm having. Okay, it was here. Why doesn't like it? Okay, so I have my play command here. I can say play, new, and I call my application Scala base. Okay, let's see what does it do. Okay, it asks me for the name of the application that I provided, and then it will ask me a question, which kind of application you would like to start. And actually, you're not doing any decision in here. It just will generate some templates and things that are, you know, to put you in a familiar kind of environment for what you're trying to do. But you can completely skip this and get an empty template, and you can, at any time, use Java or Scala. It doesn't make any difference. So there's nothing, there's no decision that you're doing here. While you're writing your code, you'll be changing. You can write some controllers in Scala, some controllers in Java, some models in Scala, no problem. You can mix them up. This is absolutely normal. This is what we want people to be doing. Okay? If you have a team that does Java, that's all right. You have some part of the application that needs Scala, well, you can introduce it that way. All right? So I'm choosing the simple Scala application, and that's it. Now if I go inside and then call play run, let's see what happens. I need the browser. Okay, I hope it will not need anything from internet. So like now it's loading the project definition, which will tell like what dependencies we will need for this kind of project. And that's actually, there's something interesting that we did in the release that is going to come, that we separated like different types of projects. Because at the first release, it was like you will start play and it will grab everything you could ever need for a play application, which means like also all the Java dependencies. But when you know that you are mainly do Scala, then we're not going to grab all these dependencies. We're just going to take the minimum set of dependencies that you'll need. And this is much better than what we have before. So this modularity, we introduced it like in 2.1. So now we see that the server is running. I can go into the browser, hit on port 9000. Let's see what happens. So here we see, like, I started the application, I started my app, and it started very fast. I mean, it started without compiling the sources, right? And now when I hit the URL in the browser, now it's compiling the source files. And why does it do that? Because actually, this is one of the main things in Play. You don't go to the console very often. What you'll be doing, you will having like your browser and your code. You will be changing your code, hitting reload in your browser, which will trigger the compilation process, right? Which means here, I got my application, right? Because it compiled it. And then if I go to my editor here, okay, and I go into, no, what was it? It was here, Scala base. So first thing I see in here, I don't see all the screen. Do you see, or is very small? It's small, right? Okay, let's try to make it bigger. Doesn't want. Okay, so again. So first thing we see here is that we got this structure of project that consists of several repositories. Why don't I have? Yeah, I have the app. So we have several folders. It looks very much like a lot of other MVC kind of frameworks, and it has an app application where your code will live in, right? So inside the app, I will have controllers. I have application. If I go into it, I have a simple action, and we will talk a bit more about this. But now, if I go here and then make a mistake, for instance, I write whatever, I remove this guy. Let's see what happens. I go to my browser, I refresh. The interesting thing is that I get the error here. So I get the error in my browser. And this is essential to how like the productivity of play, is that let's keep two focus. One is on the result, and one is on my code, and that's all. And each time I make a mistake, I want to see it on my browser. So of course, I will go to my console when I need more details, when I need more stuff about warning and other stuff. But mainly, I will be working with two things, two windows, my code and my result. All right? Now, if I go and fix it, and an interesting thing is also it shows you where exactly the problem is. For some people that configure it, you can click here and open your editor and see where the problem is. Anyway. So basically the way so play is a very small thing, right? And then we build structure around it. So play as the minimum of the minimal play is just an API for doing HTTP programming. But then around it, we put some structure because it's very familiar to people and it helps them like structure their application. Which means like if you look at the core of play, what play offers, it's really an HTTP API. But for a lot of applications, we have experience with that. MVC tends to be like a good structuring model for application. Of course, if you're not happy with this kind of structuring, then you can introduce your own. Nothing in play prevents you. You can completely remove everything and just keep the API, and on top of the API, build your own structure. But for now, like by default, it's MVC. So which means, what does it mean MVC? It means we have a routes file, okay, that will be telling you where are things. So this is the main routes file. We see like I'm getting on a get on slash, I will go into index. I will go into controller.application.index. Now if I go inside application, I see this index, right? This is where the route is pointing at, and I will see an action. So action will be sending an OK status. Okay, and that's where we talk about, like, we are very explicit about what we are sending, right? We're sending HTTP. We need to know what we are sending through HTTP. We're sending an OK status or a not found status or whatever we want to send, right? We're talking about web here. That's why here I can basically say not found. Okay, I can refresh here, and nothing changed. Well, actually, there's something that changed, which is here. I can look and see like it's a 404, right? Because actually 404 is just a status, the content can be the same thing. And what I did here is that to send exactly the same content that I was sending, right? But with a different status. Actually, if I can here say something like whatever. And that's what I will get. Right? So basically here what I was doing is I'm calling a template, okay, and I'm passing it string. And actually a template is nothing special. It's just a function. So you can call any function in here that returns something that play will understand, and it will push it through the wire. Okay? Nothing complex, nothing fancy. This is the familiar structure of having a routes file, an object that have several methods. Each method is representing an action. Okay? So far so good? All right. I will turn this back into an OK. And that's what we mean by we start small, okay? We want to send something, we start small. Here I can represent my routes and my actions this way, and then when I need more, I will add more, okay? So now, let's go back. Maybe this is slides. Any questions so far? Because if you don't ask question, I will assume that you know everything and I will go much faster. Here's a question.
How do I download JSON so I can interpret it?
How can you send JSON to the client side, you mean? So there are different ways. There is an API for writing JSON that we have into play. So I could show you maybe through the way you will see some examples of using JSON. But yeah, it wasn't a lot the focus of the talk, but there is a JSON API that we also improved a lot in the next release that you can use for writing your JSON, for getting JSON from a data store, parsing it, and then also sending it to the client. But we'll have some examples that use JSON through the way. Other questions? Okay, we're good. The next release, when there is maybe you can ask me this by the end of the talk. So we're going to have a release candidate soon, pretty soon. Yeah, but then of course it depends on a lot of things that happen on the type safe. So it's kind of the thing that is managed by the type safe, the release, and there are several things, right, that's going on. Okay, now the question is, okay, you got this framework, you're happy with it, but why to have yet another framework, right? We have on the JVM we have a lot of frameworks. Even in the Scala world we have a lot of frameworks. Now, why did we need to create yet another framework, right? Because we at Zenexity, where I work, we like to use things that do exist and that they do what we're looking for, what we want to do. But the problem is that we saw some limitations that we really want to address, right? And that's basically with all frameworks that are based on the WAR architecture. WAR being the packages that you deploy in a WAR server app. It was a bit recursive, this definition, but anyway. So let's give you, I will try to give you some context about that. So it's all about the web. The web started by these static HTML pages, okay, served from some kind of server, but they're pretty static. Nothing changes in the web page. It's just like a company page, some address, some things in there, and that's it. It ends there. And then we started like, I still remember that, we say like, oh, let's add a counter at the bottom of the page. And that was cool because the server was keeping the count of what users we got. And then it made sense, and we started adding more portions into this static page, right? We added more and more things until at some point we saw like it's getting complex. And that's where we get into PHP, ASP, and all these things where the presentation is mixed with the logic. We don't know whether the logic doesn't scale, a lot of problems, right? And then we started like, this thing is making sense, the dynamic web, but it's not the right model. Let's try to structure it more. And then we got into structured web, where we used something like MVC and other kind of structures to try to represent our applications in a more partitioned way, like where we care about different things in different places, where the view is separated from the controllers, separated from the model, so that we can reason about things in a more elaborate manner, right? And that's when the structured place. And then we got this structure, we could do a lot of business with it, a lot of applications, and then suddenly we started like saying like, hey, there's something cool. And it happened first in the Microsoft Outlook client, that we could add some dynamic parts in the page, but without refreshing the whole page, right? It's so cool. Like we can add some, we call it Ajax, right? A portion of Ajax in the page without refreshing the whole page. And we started like adding these more and more of these. And at the same time, we started having web applications, something like Facebook and Twitter, which are all the time using this Ajax thing, but all the time serving new data. It's like you can imagine them as streams of data all the time. You get a stream of data. You open Twitter, you wait seconds, you get more tweets, and it continues, right? Facebook the same. Everything is moving. It's real time. It's not anymore refresh, or click. It's like the website is not anymore something static, but it's rather like dynamic. But we haven't changed anything at the server side. So we get into the limitations of that model anyway. And we need a new model, new programming model that can handle these kind of new stuff that we need to do with our web applications. And that's exactly why we thought like we should address that with Play. We should do a web framework that takes into consideration these kind of things, right? The streaming stuff, to have a programming model that is capable of doing this kind of streaming stuff. Okay, so that's one point, which is the programming model, right? The first point is we need a programming model. Okay, now the second thing is the whole architectural model that is kind of limiting, right? Because all the WAR architectures, they are based on the fact that I get to the user, I give it a request, to users, to requests, and so on. Sorry, I get a user, I give it a thread, 2 users, 2 threads, and so on, until I get like hundreds of users, hundreds of threads, and it's kind of limiting because for several things. First, threads are not for free. That's the first thing. Second thing, more importantly, is that mostly in a modern web application, you will not be doing much on your app server. I mean, you'll be calling a lot of services that are distributed and waiting for the result. Now, while you're waiting for all these app calls, like API calls that you did, for instance, like REST APIs or whatever you tend to use on network or trying to read files, in the meantime, your server is doing nothing. It's just waiting, right? And it's kind of, it's not so good that you're blocking resources like threads where you're not doing any work, not on CPU, not on anything, right? So imagine I get a request from a client. To satisfy that client, I have to call 4 REST APIs, okay? In the meantime, I'm waiting for these guys. I'm doing nothing, but I'm blocking a thread. And we don't want to have that, right? And that model made sense before, because the whole web application idea was a one-box thing, okay? Where it was communicating inside this one machine, one box where you have the database inside and the application inside. And anyway, everything is in the same machine. It makes sense to do it that way. But when you're distributing your model, you need to think about it in a different way. You're doing a lot of web calls, a lot of network calls, and you need to think about like not blocking resources for things that are happening on other machines, right? You need to be able to handle these in a better way. So, and mostly, like, so you might know already about it, but network calls, nothing is happening on the machine. Everything is happening on another machine. And there is some, at the operating system level, there are some non-blocking APIs that will notify you when something is happening. Okay, so you can start a web call, and the non-blocking I/O will tell you, like, here, I got some information. Then you can react to that. Now, you can react to that and do some work, and maybe schedule another API call. And now you can leave it. And when you get the next notification, you can go, take over and continue doing some stuff. So what I told here is that we are reactive, right? We're not proactive. I'm not starting things and waiting there for getting the job done. But rather, I'm throwing something to do, and I'm getting notified to continue working on that task that I'm trying to accomplish. Okay? So that's a new model. It's a different model of architecture, of execution, a different execution model, right? The question is there a difference between asynchronous and reactive? The short answer is yes, and I'm going to address it afterwards. Okay, so what we need is, there's a question. So what we need is something that is non-blocking, right? We're not blocking any resources. Reactive, which means I get notified when there's something, and then I can go on. And now what about asynchronous, right? Because often, like a lot of frameworks out there, they will go talking about like, hey, here's my framework and it's asynchronous. I'm like, okay, what does that mean? Like, it's completely asynchronous. And like my only reaction I can say then is like, wow, this is hard. You're telling me your framework is asynchronous. Wow, it means I have to deal with asynchronous stuff suddenly now. Why? Why would you want me to do that, right? It's the synchronous model is so easy, and you want me now to do asynchronous. Now tell me what's the advantage. The asynchronous is not the advantage. The asynchronous is something I will pay for. Now tell me why would I pay for that? And now, of course, you can talk about advantages that will make you accept being asynchronous. So there's 2 things. First, the question is, what are the advantages that I'm looking for? So it could be non-blocking reactive, okay. If you give me non-blocking and reactive, which is good, it can be scalable, then I can pay the price. Or it could be for concurrency, parallelism, whatever other reason. I tell you like, okay, you can now use a lot of CPUs if you accept of being asynchronous, okay? So you're paying the price of being asynchronous. You know, you need to know why. So next time someone tells you, oh, my framework is asynchronous, you should ask why. The first question. The second question is, okay, if I'm willing to accept this asynchronous kind of model, now give me the tools to handle this. Because you need to be able to handle this kind of new kind of programming, right? That is not as easy, as simple as the synchronous kind of thing. So 2 questions. Why should I do that? And then give me the tools. And in Scala, fortunately, we have some way of dealing with asynchronous stuff, right? We all should know about it already. It's already in the Scala 2.10. It's the Scala futures. And Scala futures will take, okay, we'll say, okay, we have this asynchronous problem that is, we know that it's hard. But we got these futures that represent something reactive and asynchronous, and we can compose them in a way that we can handle asynchronously in a safer way, because it's really a hard problem. Okay, so Scala gives us the tools to handle some kind of scenarios of being completely asynchronous. All right, does that answer your question? Cool. Let's move on. So let me show some examples of how do we do that in play. So I will kill this app. I forgot what I was saying. Starting being asleep. Okay, so okay, that seems good. Okay. No, not you. Wow, what's happening here? Okay. Okay, so let me run it. So I go to my editor, and I'm going to open this app. That's really not very interesting, but it kind of illustrates one point. So let me go to it. So here I have one promise, and then I have app, controllers, and application. So as I showed just before, okay, my action was simply returning an OK status, okay? But there's another way of doing it in play. You can return something we call a synchronous result, okay? You can return just a result, which is OK, not found, and all these kind of status. But also you can, these kind of results, but also you can send something that is an asynchronous result. And what does it mean that? It means like instead of sending me a result, you can send me a future of a result, okay? Or promise of result. It depends which vocabularies you're using. But the future of result, if you use the 210 vocabularies, which means like I can get any future from any API, and I can give it to play and say like, okay, handle this kind of case. You got a future. Whenever you have the value there, we'll give it to the client, right? This is exactly the same action, and that's what I said. Like you start with the action, but you reuse the same structure, but now you are returning an asynchronous result instead of the result, what we had. And I have here a promise, okay, of int. So for those who don't know what the promise of int.
I have a question. Does that async result do it just a flatten? It looks like that.
It doesn't do any flatten or anything. It just takes as a parameter a future of something.
I see a map coming back, so I expect a list, and there's not a flatten.
It's a map of the future. Okay. So I will explain it a bit. So here I got a promise of int, which means at some point, eventually, someone will be pushing a value into this promise of type int, okay? And here, what I'm saying here is for anyone that is hitting this waiting route or waiting action, I will be sending an asynchronous result that is based on the future of this promise, okay? And I will be, whenever I get the value, I wrap it in an OK status. Okay, so basically what I'm saying is when I eventually get this result inside this promise, I'm going to push it to the client. As simple as that. And the map here is saying like, okay, now whenever you get the I, you need to apply this transformation to it. So I'm mapping the value inside the future of that particular promise, okay? All right. Now I got another action that is the redeem action. Redeem action is basically we'll get an int from somewhere, and all it will do is to push it into the promise. So it will redeem the promise. It will success the promise with this integer that has been passed to it. Okay, and then it will return just an OK message. Okay. Now I got the index action with the third, which is a third action in this app that is simply doing an OK and calling this template. Okay. Now let's look at the template. What is it doing? The templates tend to be in app views, index. Okay, it has a lot of code in here. Well, it will, because I'm counting from 1 to 500, so a range of 1 to 500, and for each so I'm having 500 iframes that are pointing to this to the waiting index. There are 500 that will be trying to get this result, which is we're getting from the promise. Okay, so let's try to run it. Right, we have this waiting that is getting this promise and into an OK. We have the redeem that will be redeeming it. Let's see how this will work. Now I open my browser again. Okay, I point to localhost, and I see the 500 frames. Right, that's good. Now I open another. No, it will not happen in here. It's a post, I guess. Well, let's look at the routes. It will tell us, no, that's my other thing. Okay, so here in conf, routes. Okay, so we see here I got a post with /i that will call the redeem, and we see the other routes. Okay. Now, if I go into cur, I always forget how to write it. If I do a post to localhost, oh, I can't write it right. Okay, I will do that. You see, I'm sleeping, right? Okay, // I thought it will fill it for me. Okay, and then slash, let's say 2. Okay, so okay, so what I'm doing here is I'm doing a post into this thing that will go redeem the promise or success the promise with the value I'm passing here, right? So let's see what happens when I do that. Give me my browser, and then this guy, and I'm going to hit enter here. We see like it's starting giving everyone the value, right? It's Chrome, it's taking some time, but basically what was happening and all the time when I'm trying to type all these is play is doing nothing. Playing is not blocking any resources, nothing is happening at play, because actually there are 5 open sockets, that's right, there are 500 open sockets to the, well actually less than that because the range doesn't take all the range, but that's another problem, it's 499 I guess. Of open sockets to the server, but that's it. I'm not blocking threads. There are not 500 threads. There's nothing going on. If you open Visual VM, you see that nothing is going on in the meantime, right? Because it's just, okay, play says, okay, I got that there is this promise. I'm just, when I get notified with the value, then I will send this message to all these sockets that are connected, and I will close them down, okay? And that's very essential to the architecture of play. So play is basically, so it's essentially based on these futures, okay, and promises. It's in the core of play. That's play's way of doing reactive programming. Yes, question?
What happens if you reload the page with 500 requests?
Well, it will just give it right away because the promise is global, normally. Yeah. Any other question? So the example is very simple, right? But it shows you one very essential part of play is that the fact is that based on futures, okay? That's all right? We move on? Okay. Now I don't know what should I illustrate the next one.
If you do another post, it's different.
That's it. So if I do another post, I will try to re-redeem that particular promise to success it, and it will throw an error because you can't do it twice. I can show it if you want. There, you get the error. Okay? So, okay. That was a good promise. Now, of course, this sample was very trivial. It was even almost not interesting. But you can imagine that instead of having this promise this way, you can get a future from anywhere. You can get it from a web call, you can get it from another library. Anyone that can return a future you can integrate it into this kind of process and into this action. Not only that, anything that returns a callback, you can implement a future on top of that and then use that for integrating with play. Okay? It's very easy, very simple. Any API that will provide a callback, you can integrate it with this kind of model. Okay, including ACA actors. So mostly there are a lot of people, and I guess at Cloud you do this, is that you have some ACA actors, you do some jobs, they give you futures, and you tell Play, whenever the future has a value, then go and write it to the client. Okay, but now all of that we're still talking about one value, right? Sending one value to the client, only one thing that is computed, buffered, and sent, right? But sometimes you need to work with streams of data, not only one message, but a lot of messages, right? And that's when it gets even more interesting, because you need to have some properties. So let's see an example of that. Okay, this one. I can't see what's happening. No. Oh, I don't need you. Okay. So I don't want all of these. What did I do here? Okay. So I go back and I go in. Okay, this guy maybe. Okay. Okay. So one of the things that we can do with play as well, because you've seen here, what I do is it's a simple action, and I try to see what's inside the request, and I do something with it. But what if you need to handle the request body in a different way? Now you could ask me, why would you need that? Well, there is a very important thing, like what goes in the request body? Well, everything you upload goes into the request body. Okay. Now let's imagine what happens. Okay, if you do it the default way, which is like, so how can we handle file uploads? Well, most frameworks what they will do is either they will get all the file into memory and will give you access to it, that portion of memory, or write it on the file system and give you access to it in the same way, right? And in both cases, you have a problem. So you're filling memory for something you might not be keeping in your server. So imagine I can have an application that is taking this file chunk by chunk and sending it to S3. So basically, I'm not keeping anything on my server. I'm just forwarding it to a server like S3, Amazon S3, and putting everything there. So it's kind of a shame to put everything into my memory before sending it to some other service. Imagine I'm uploading like a file of like 500 megs for each user. If I got a lot of users, I'm screwed, right? I have too much memory usage or disk usage or whatever it is, right? But the problem, there's another problem, is that if I go and stream it, okay, chunk by chunk, now what happens if Amazon S3 is slower than the guy that is uploading the file? There are different things that can happen. One of them is that I will be forced to buffer it at my server or to lose bytes. And in both cases, it's not a good thing. If I'm buffering, then I'm again putting the whole file into memory, which is really not good. Okay? And if I lose bytes, someone will be angry because of that. So what could we do in this kind of case? Now let's see in play. Let me see, where is it? So first interesting thing is that in play, we allow you to use your own body treatment, a request body parser, we call it. Okay, that you can pass your own body parser that will be treating the chunks of the body. So let's take a look at that. It's inside. Okay. Okay. So basically, in the API. So you saw that the common structure for the action, well actually the action here, as you see it here, this index guy, this guy, you can, before passing the body of the action, which will be doing the actual stuff and returning the answer to the client, returning the response, you can also pass a body parser. And actually body parser is something that will be taking chunks of data, okay? And when it's done taking these chunks of data, it will produce some result, okay? So for people that use the Scala list API, it's like a fold, okay? Now a fold, list, when you got a list and you fold over it, you're going to compute one value out of all these values that are in the list. Now this guy, the body parser I got here, is exactly the fold method, but it happens to be a bit more interesting, is that it can take progressive chunks. So chunks that I don't have now. It's very progressive. So I can give it a chunk, and then I give it again another chunk, and when it's done, it will give me that value. Okay? So basically, you can imagine it as a state machine. It's a state machine. Each time I give it a chunk, it tells me what state it has. And at some point, it will give me, I'm done consuming chunks. I don't want any more chunks, and it will give me the value that it could compute out of these chunks. Okay? Very simple. We'll get chunks of data, and at some point, it will return a state that is done. And for that state, I can take the value and do something with it. Okay? And that computed value, it will be inside the body. It will be the body of the request. So basically, your action will be two parts. When the body parser, that will be processing these chunks of bytes that you get from the request, and the body of the action that will take this body and do something with it, right? Now the body should not, can be something else than the whole bytes of data. Imagine you're sending to S3, so the body will have only the handler to where you save the file, right? If you're saving on disk, it will be the handler to where you saved on disk, and so on. So the body is not all the bytes, but it's whatever makes sense for you to put to use into the action body. Okay? Yes, question?
Yeah, I was just curious about the iteratees.
And I didn't mention iteratees, but you're right, it's iteratees. Yeah, go ahead.
Well, I was just curious about Play's iteratees and how are they different from Aka's iteratees, Scala's iteratees?
Well, Aka doesn't have iteratees. How they're different from Scala's iteratees? It's
well,
kind
Aka
of.
has in the I/O they have one.
I didn't see it. Maybe there is one. I didn't see it. Okay. You're certain of this?
Yes, I use it.
Wow.
That's why
Okay.
I was curious.
An iteratee.
Yeah. Yeah.
Okay, I should look through it. Anyway, but I can tell you the difference with the Scala Z1. Okay, but let's take over this afterwards because it's kind of I didn't introduce much iteratees and it can be confusing for others. There are some tiny differences between them. We try to adapt iteratees for the use of Play so that they are closer and they are kind of let's say kind of simpler in the use case that we're trying to do. Okay, but then we can discuss it further. Now, so the iteratee that we're talking about is actually this body parser is basically, it takes the request header and it returns an iteratee, okay? So I got this body parser. Well, let's try the first one. So this first body parser, what it does actually is it will take, so it's a fold, right? Why don't I see everything, do I? Okay, so the first body parser, it's a fold. No, here it is. I will make some distance between them. So here it is. It starts with 0. Each time it gets a chunk, it adds 1 to that 0. It's a kind of fold, and it's just counting how many chunks it got. That's it. It's receiving chunks, counting 1, and then throwing that chunk away. It's not keeping anything, right? It's very not useful, which is useless. Okay, so, and then I pass it to the action, and here I get the body, which will be, what will be the body here? Yeah, the count of chunks, how many chunks I got. And then I send it in OK status, right? Very simple, nothing fancy there. Now let's try and run it. I should find where play is. Actually, I work on different versions of play because I tend to be on master and others. That's why I never, yeah, I have to find where my play is. The one I want to use for the samples. There it is. Okay. Okay, we got it running. If we go and hit the URL, nothing will happen because I need to post that file. It's a post action. We'll see here, it will tell me like, you don't have anything that you want to use in this particular kind of request. So it's the first time I'm starting the application. It's like trying to compile everything. Come on, come on. Okay, there it tells me you got only a post on slash, and that leads to index. Okay, so I'm going to do the post from cur. I just saved it here because I don't remember it all the time. Okay. So I'll open one new. I will go into downloads. Okay, it's in here, the downloads, and I do this post, and I get these many chunks that has been sent to the server. Okay, so actually my client, which is this cur, have sent these many chunks. So it cut this file into chunks and send it chunk by chunk. Okay, nothing fancy. But we could count these chunks without even saving them anywhere, right? We just get them, count, and throw them away. Nothing in memory, nothing has been like, play didn't explode memory because it doesn't care about these chunks, right? And this is interesting. What's more interesting here is that the question is, what if I got something slow that is handling these chunks, which is not as fast as the user that is trying to upload this file. And basically here I got another body parser that will not only fold, but each time it folds, it sends a future. That future that will be happening in 500 milliseconds, which means it's taking, basically what this means is that it's taking 500 milliseconds to handle each chunk it gets. Okay, now we can imagine this is a web service call, network call, because I'm sending these chunks. You can make it as slow as you want. Okay, and now we got a future. Now, what we want here is play to handle this in a clever way, because it has a signal, right? It has a signal that will be saying like, okay, I'm not going to complete this until this future is complete. Okay, now let's see what happens if I use this. Sorry? It's very, okay, it's very weird that each time I do exactly the same mistake, so I got some problem, I guess, in my brain about this. Each time someone will remind me, you didn't change the action. Or maybe I do it in purpose to see like people are awake. Let's claim that. Okay. So compiles. Okay, nothing happens here. I will repost here the same file. Okay. Nothing happens. It's still doing some work because we handle the chunks. It's very slow. Okay, and if we see here in the app, we see that it's receiving chunks, chunk by chunk, right? Now the interesting thing that is happening here is that I'm slowing down the client that is sending the chunks, which means nothing is arriving to play. I'm slowing down the upload at the browser or at the client side because I got the right signal. Which means like integrating this future mechanism got me this reactive stream that I'm using so that I can even slow down the upload. So wherever I got like too many bytes, I can pause the socket and the client will not be able to send me anything until I handle all what I got, and then I can resume it. And that's taken care by play, which means in our question, when we're sending to S3, if the network that way is much slower than what we're getting, we can even slow down the client. And that's what we talk about when we talk about that's what we mean when we talk about reactive streams. Okay, so that's streams that are reactive all the way down. Okay, so if everything that is slow here in consuming a stream, well, we have the opportunity to slow down the stream itself, right? If we want. Of course, we can do other things. In different scenarios, you got different things you want to do. Sometimes you want maybe to discard some bytes because it's okay to do that. Sometimes you want to buffer until some limit and then crash. You have all these semantics you can implement on top of these reactive streams. The important thing is to get this reactive stream there, and you can do a lot of stuff on top of it. All right? I mean, normally I should here open Visual VM and show that there's no memory. I'm sure you trust me. I see your faces. So now the question is, what can I do with that? Yeah.
Is that what you meant by composability in the title of the talk?
We'll get into that. That's not composability yet. So we got what we need for composability, and I will show why. Yeah. Question.
What determines the chunk size?
What determines, it's the browser often, so the browser will determine the chunk size when he sends, but if the browser sends big chunks, then at the server when we receive them, we chunk them as well. Okay, so Netty will be also chunking the bytes as it receives them.
So if you have an uncooperative browser, you would send them.
We chunk them our way. Okay?
What's that?
Sorry?
We chunk them what?
At the server side, we chunk the bytes as we receive them.
Is that controllable?
No. It's like there is a limit we set at Netty to like how much we should chunk this kind of thing. But we can pick up on the subject after. So now that we got here, like I would like to see an example, a real example of. Okay, so of using this thing. So I have this sample that a colleague of mine, a coworker at Zenexity that did for me. I'd like to show you. So it's this reactive. Come on. Okay. What did I do? Okay. So I'll start this app. Oh, I have to start another thing. Okay, I can start. How can I start this app? Not this one. Okay. I should use another play here. And I should be using Mongo. So to have this sample useful, what could we do actually is use MongoDB. So MongoDB got this feature that's called GridFS. GridFS is basically a way to store files inside Mongo. It will like chunk files into several parts and save them there. Now, if we can get a stream out of Mongo, when we want to send these files into the client, and have a way to send also chunks in a reactive way, progressive way into Mongo, well, that's all what we need to implement this feature that we got. And actually, at my company, Zenexity, we do this kind of stuff, and that's why we implemented a driver the driver is called reactive Mongo. That does, so it's kind of an integration, okay, of MongoDB functionalities into the Scala world. Okay, that will use futures, iteratees, and so on. Okay, so this example will try to illustrate that. So let's go into. Okay, it should be in localhost. It's not running. Go ahead. So basically, I have a lot of samples, and what I want to give you is ideas, so that you can take all these ideas, think about them, and think what makes sense for your kind of context. But I want first to get the basics, right? What exists in play, and then to give you examples so that you can use these kind of things. So if we go here, I refresh this page, and it's compiling. So maybe I should okay, who is counting to leave in 30 minutes? 1 hour? 2 hours? You're not leaving, guys. Wow. Okay, that's good.
Are you going to be up in 2 hours?
I did 2 hours and a half yesterday. I don't know how many hours, right, Mike? Yeah. So I can do 3 hours. They kicked us out, actually.
We made them stop last night after 2.5 hours.
I got a lot of stuff, I can say. So I got these albums, and I can start a new album. I will call it, I don't know what. Well, actually, it happens. Okay, I have already this one. I will call it Puerto Rico 1. To come to San Francisco, a direct flight will cost too much. That's why I went through Puerto Rico, spent 5 days there, and came back here, and it was cheaper, including the hotel. And that was a good experience. It's good being in Puerto Rico. That's why I'm a bit relaxed, because I was on vacation, right? So Puerto Rico, there we go. And so this is basically an app that will take all these features and implement them for an image upload, right? So I can get this image, wonderful images that I took. I hope not to choose the wrong ones. That one is fine. Okay, here's an image. So it's basically what it's doing is taking the chunks and sending them progressively and reactively to MongoDB, and then downloading them from there, right? And this is also very scalable thing. And we're not putting into memory anything. We're doing it progressively towards the Mongo and from Mongo. So basically what's happening here is that when I'm sending, we're doing exactly the upload thing that I did. But when I'm getting, it's also very reactive. So Netty will give me a signal each time I send some bytes to the client. Each time is done sending bytes, it will tell me I'm done. And now I can advance the cursor on Mongo to say, like, give me more bytes on that, and so on, which is also downloading at the speed of the client. So we are pulling from Mongo on the speed of the download of the client. Of course, we can implement on top of that something that will, with timeouts at some point. This is very easy to implement, but the idea is there. So we have the basic stuff that we need to implement these kind of functionalities. I'm really afraid about the images, but it seems to work so long. Okay, now 3 are sufficient, right? Yeah, it's very good to be there. It's beautiful. I can see all of it. Okay. All right, now we get the idea, right? If you want to use and to try this plugin, it's Reactive Mongo. You can find it online. I got a GitHub. It's on GitHub somewhere. It's an XTT Reactive Mongo. Okay. And question?
Yeah. So I take it because you have that project, Reactive Mongo, components in play can be used outside of play, outside of web framework. So if you want to use iteratees, but let's say not in a play app, like play iteratees, but you have something that's not necessarily a web app, or play JSON.
So, okay. Okay, so there are these 2 examples of some library that you could use like outside of play. You could. It's not our focus, so I will not tell you that I will be. Okay, if you use them, you ask questions, we'll answer them. It's very easy to use them. Actually, today we got them even outside of the core project. We have a special project for iteratee. JSON is not the case yet, but we are happy with that. But anyway, we're not working a lot for people using them outside of play. What we focus on for the time being, and maybe afterwards we'll be trying to do that, right? If it makes sense. But for the time being, what we're focusing on is having a toolbox inside play that allows you to do all the kind of tasks that you need to do when you're doing web programming, modern web programming. And we need to get these tools inside. Now, at some point, if it makes sense, we might think about maybe externalizing them or putting them into other libraries, but that's not the focus for the time being, okay? But you could use them, and there are some samples that use them outside play, okay? Cool. Now, what we got here? Okay. Okay, I'm going to kill this app. What am I going to do? Okay, let's move on. I'll kill this one. So now I have, I'm just afraid I missed some samples. I didn't miss anything. Let's hope not. Okay, so now all what I showed are just the basic architecture, right? We got this reactive futures-based core with reactive streams based on what we call iteratees that I didn't explain much, okay? Now that's the core. That's the core architecture inside Play. But I didn't talk a lot at all about real-time web, which is completely, it's a different thing, right? But it tends to be very interesting and very easy to implement real-time web on top of what we got inside Play. And actually, that's why we got this architecture, is to support real-time web. So now the first question is, what is real-time web? The real-time web is being able to have a continuous communication with the client, between the server and the client. Sometimes it's bidirectional, sometimes it's just from the server to the client. It depends what you need, right? But it's like the thing that we mean when we talk about like long polling, we talk about comet, server-sent events, or WebSockets. These are all some kind of protocols to be able to support some kind of continuous communication between the client and the server. Now, why would we need that at all? Well, today, if you are on your Google document, when you type a letter, okay, this letter is going directly to the server because the other peer is seeing what you're typing, right? Now, if each time I want to push this letter into the server, I send the whole HTTP request, well, that's a lot of bandwidth, right? Because the HTTP request is very big, whereas I'm sending only one single letter. Okay, that's a lot of bandwidth. It's not going to work. I mean, it's going to work, but it's we can't handle this kind of bandwidth, right? Now, that's one of the problems. But also the client. Let's imagine I'm the other peer receiving these these letters that you are writing. Now, how can I receive that? In HTTP, basic HTTP, each time I want to receive something, I should do a request. Okay? So I do a request, I receive something, I do another request. So the first way to implement this kind of continuous communication is, for me as another peer, is to keep polling the server. I ask the server, give me the new information. And if there's nothing, then the server will wait. Okay? And we saw the kind of wait mechanism that we have in Play. You can have some reactive waiting that is not consuming any resources. That's already good. Okay? And when you get a message, then you get this answer, and then right away you start another thing until I was there, what you have new, and so on and so on. And of course, it's not as efficient as we want because we're doing a lot of requests. From the other side, we're putting a lot of data into the response. That's not good. Now, that's why we started like doing other stuff for trying to simulate this kind of continuous communication. And one of them is what we call the server-sent events. The comet. So we start hearing about comet. So what's comet? Comet is a kind of hack on top of HTTP 1.1. Now, what we got in HTTP 1.1 is something we call chunked HTTP. Chunked HTTP is basically the fact that it's a protocol on top of HTTP where you can wrap each message. So you have a huge message you have to send, and each chunk of the message, you wrap it in some protocol. It's a very simple protocol based on new lines and length of the chunk, okay? And the browser, when it gets this kind of protocol, it understands it, and it can already show some parts of the answer. So imagine you are sending these kind of chunks to the browser. Let's say they are chunks of an image. The browser can start showing some of these parts of the image before it receives the whole image. And it was kind of optimization, so they can progressively send a response, and the browser can show it. If you get a long page, you can have this kind of mechanism of showing parts of the page until you get it all, right? This is kind of progressive sending and displaying of an HTTP response. That's HTTP 1.1. Now, we looked at it and we say like, oh, that's cool, but what if I send script tags, okay, as chunks? And the browser will be receiving one script tag, and it tries to understand it and execute it, right? And each time it receives a script tag, it will execute it, and so on. Now, if I send a script tag that is calling a callback with some message, now I got a continuous message flow between the server and the client. And that's the hack on top of HTTP 1.1, right? It's basically receiving these kind of messages, all right, from the client, from the server, that are basically scripts that are calling some callback. And I will show an example into that. So here we got something. All right. Okay, so I'm here. Okay. Controllers, application. All right. So basically what I got here is this stream that I call clock. So it's a stream of clock values, right, that I'm generating here. It's a stream, so this enumerator, it's kind of represents a stream of things. And this is a stream of string values that will be generated by calling a timeout of 100 milliseconds. And each 100 millisecond, okay, I'm returning a future of a date. So actually, it's a stream of date values that are happening each 100 milliseconds. Okay, so a stream of date values and with a distance between them of 100 milliseconds. Okay, so that's a stream of data. I got a stream of data. Okay, and now what I'm doing is I'm streaming this stream. Okay, and I'm adapting it using this comet adapter. Okay. Now we got two notions. We got a stream and we get an adapter. Now the adapter actually basically the adapter will be doing is taking each chunk and adapting it in some way, or taking several even chunks and adapting them somewhere. That's why we got two things now, right? The stream, which is represented by enumerator, and the adapter, which we call enumeratee. Okay, and in this case, this comet adapter, so we're passing the stream through this comet adapter. And the comet adapter, what will it do actually, is it will take each message, wrap it into this script tag, and into a callback that is here called parent.clock change. Okay? And I will show you more details in a minute. Okay? So basically, what will tell in play, well, you're going to send an OK status, streaming this stream that we are passing into this adapter. Okay? Now, the other part of this is at the client side. Now, let's see how the client side is handling this. Well, we see at the client side, there's something called, so there is this callback that we talked about, clock changed, okay, that will be taking the time and it will be replacing it somewhere in the page, right? So at the server side, we take these messages, we wrap them into script tags and into a callback that will be calling back this function that we set on the client side to receive these messages. And that's the whole hack, what the whole hack is about. Okay? Now let me try to run this, this application, which is not here. Comet clock maybe. Okay. No. Okay. Now, if I go to my browser, okay, and it's not working. Why is that? Illegal start. Maybe I deleted some stuff. What did I delete here? Oh, this guy seems odd to me. Okay, well, let's kill this guy. Wow. Okay. Okay. I'm going to comment out all of these because it doesn't make sense here. Okay. I refresh. So, I couldn't. Okay, I will put it back because it doesn't like the fact that I remove it, but I will just, I will put it here. Okay. I'm fixing the sample that I broke yesterday. And we kill this guy. Okay, let's start. Let's try this way. Okay, seems to be working. Okay, so we got the clock working. It's getting values from the server side. Now let's verify a few things. So how does this work? I will see here in the page, if you can see on the screen, there's an iframe inside the page. This iframe got the document inside it. Inside the document, there's HTML, body, and now you'll see a lot of script tags. So this is actually what is getting streamed from the server. These script tags, each of them is calling this parent.clock change of this particular value, and so on. So we have a lot of them, right? So this is the kind of communication that we got on top of HTTP 1.1. Okay, we got our stream, we adapt it with our particular adapter, and then we push it to the client, and that's how we can get this sample working. But there is a better way of doing that. There's a protocol that properly implements exactly these semantics without doing a hack on top of HTTP 1.1, which is called server-sent events. Server-sent events is very close to the HTTP chunks, okay? But it's basically done exactly for this purpose, which means like I can just make at the client side new event source, and I can make like have a callback on that and do something about it. And from the side of play, basically the code will be exactly the same. I will just be using the same stream, but just I will adapt it through another protocol, which is the event source protocol, okay? And adding the proper headers. And that's interesting because I'm introducing something called a stream, and then with the same stream I can adapt it to support two kind of protocols. Nothing magical, right? It's just an adapter. A protocol is just an adapter on top of my stream that I already have, all right? And that basically gets me to a point that I wanted really to illustrate something very important. So let me go back to the slides. Okay. That when we talk about, so real-time web is long polling, comet, server-sent events, and WebSockets. WebSockets is being the one bidirectional, but we know with the other protocols, you can, everything that is going from the client to the server, it could be an HTTP request, could be an AJAX request, and everything that's coming by it could be commit or server-sent, but that's details. And actually, the important thing about what I just showed is that you need streams to be non-blocking, first of things, and you need a programming model. And actually, so most frameworks out there that try to talk about real-time web, what they tell you is that, okay, this is what we got for you. We got an on message, okay, where you can have a callback and do something with a message, and you got this out, which you can write to, right? So this is kind of an imperative way of doing this kind of stream thing, real-time web, let's say. But there is a problem with that. Okay? Now, who is satisfied with this kind of model? Now, what's the problem with this model? It's not composable. And that's when normally in this talk, not in here, but normally in this talk, I would say like, okay, if you're satisfied, we do have it in play, you can use it, and we can go that path, or we can show why this model doesn't hold, okay? And all I'm offering is the truth. Right, we're going the red pill. Okay, so we need to talk about streams. It's very important when you do in real time to talk about streams, to be able to talk about them as first-class citizen in our programming model, right? So today when you talk about any value, you talk about list, you get a reference to the list, you reference it, right? And you take it, you pass it around, you give it in parameter, exactly what we do with functions, right? As first-class citizens, we reference them, we pass them as a parameters, we can get them as a result, we manipulate them. We know what they are, right? We know what they are. We can, you know, play with them. And that's what we need to do with streams. We need to be able to think about streams, not have something weird where I can push things into. That's not a stream. A stream is something I can grab, I can reference, I put in the value, a val, I can put in a map, I can do a lot of things with it, okay? And I want to be able to adapt them as well. If I get stream, I want to adapt it a bit, and then adapt it again, and so on, to get something done, right? I want to manipulate streams. And this is not helping me to do that, right? Now, does this particular piece of code remind you of something?
Servlets.
It should.
Servlets.
Right. Thanks, Philippe. So it's exactly, we went back to before the structure stuff, where we were like only out.println, out.println, and so on with the servlets. When we didn't have any model of talking about views, talking about things that we want to produce, right? So we kind of going backwards. And I have even a better proof that we're going backwards. So the same thing here, we got like onMessage. OnMessage is a kind of callback. Now what happens if I'm waiting for, I have two streams. So I have two messages. Now how can I say I'm waiting for these two messages to be able to produce something? I have absolutely, I want to combine these two streams, right? And I got the onMessage here. Now what should I do? I start like maybe logs, synchronizing, putting variables, global variables. It's really very hacky and very tricky, right? And because I'm not talking about the right programming model, not the right paradigm, we get into the callback hell, right? So that's not what we want to be doing. We got a very powerful language, very powerful paradigm in the language, and we want to use that, okay? So we want to be able to manipulate streams. Now, something interesting, like in Java, we did have something that represents streams. We got input and output streams. Now, input and output streams have been designed like a lot of years ago, maybe 15 or more years ago, right? But they have some good things inside them, is that they represent streams. I can take an input stream, I can reference it, right? I can talk about it as a stream of coming. Input is something coming from somewhere, and output is something like I'm pushing into. So it's kind of okay kind of model, right? It's talking about streams at the right level. It has a particular problem of being blocking, and that's what we will be talking about. But it's kind of, are we moving backwards? I mean, we had something that talks about streams. Now we get back into a callback thing, we're on message. So we should not be doing that. We should get back into understanding streams. Now the problem, of course, with input-output streams is that they are blocking. Well, what do I mean by blocking? So if I have an input stream, okay, input, and I say read to get some bytes, okay? Now, if the other party that is sending byte, if they choose not to send any bytes, I'm blocked, waiting for any bytes. And I can be blocked forever. And this is some kind of, you can bring a server down by sending one chunk and then stopping, opening a new socket, sending one chunk and stopping, and so on and so on. And then it will be all resources taken because you're just blocked on all these calls, right? Because the read operation is blocking. There's no way that I can know. There are some hacky ways, but it's in the model. You don't have a way to say like read, and whenever you're ready, you give me the message, right? This reactiveness, we don't have it. We want to have this kind of reactiveness. I would like to say like, okay, whenever I get a message, this is what I will do. And that's what we showed, what we got in the iteratee model, and the model we got and play with together with futures and iteratees, okay? So streams are first-class citizens. We got streams, we got adapters and sinks, okay? it's a kind of rewording of what we got. Is enumerators, which represent the streams. We got adapters, which are enumeratees, and we got iteratee, which is a thing. Okay, so there's the stream, the adapter, the consumer, if you'd like. Okay, now why did we use these names? Because they are names that do exist, and we didn't change them, and just historical. Okay, but they tend to be a bit confusing. But you can do this mapping, and you will understand what they are. So now let me show you some examples of using these streams. So what should we start with? What should we be starting with? Strange, I have an exception. Okay. So which stream should I be doing? Okay, so I have, so one thing you get with Play, when you download Play, you get these samples that come with it, and that you can play with. And it's really interesting to grab a sample. It can be like using streams or using like the validation API, whatever it is. You play with it. You try to introduce your own constraints, your own things, to be able to think about, to understand more how Play works and what you can do with it. So download the samples if you have time, and then play with these. So I'm going to use one of the samples that we have in Play. Okay. Where is it? It's in samples, Scala, and live monitoring, whatever. I don't remember. Okay, live monitoring. Okay, now I should run it. So let me open it with my editor. Okay. I'm particularly slow at typing, so let's be with that. Where was it? Samples, Scala, and comet live monitoring. Okay. Now we know the structure is inside app, and controller and application, open, and let's zoom in here. So what we got here is, what I want is to have this object streams, okay, that we can imagine that it's our model, right? And inside our model, I got different kind of streams. I got one stream that is sending number of requests per second we're getting into the server. Another stream that is streaming the heap, and a third that is streaming CPU. All right? So basically, each of them is basically just polling, right? Because you see here, it's using a callback that is returning each time a timeout. So it's sending the value of request per second every 100 milliseconds. Here is sending the heap size each 100 milliseconds, and the same for the CPU. Okay, so basically it's kind of we are constructing 3 streams of strings. So this is a stream of string, and the third is stream of string. We have 3 streams that are basically polling each 100 milliseconds and sending these values to the client. I mean, doing a stream out of that. So I can even type it here. It will be an enumerator of string. Okay, I got 3 streams in this stream object. These are the streams available for me. And now what I would like to do actually is, in this action, I will retain an OK status, and I will stream the first stream interleaved with the second and with the third. So what I'm basically doing here, I'm interleaving these 3 streams. I'm merging them. Okay, I have 3 streams. I merge them. I get 1 stream, and then I adapt it, using the comet adapter, and stream it to the client, like basic stuff, right? But this is interesting here. I got several streams, merge them, send them. Okay, we're talking about streams. That's why it's extremely easy to talk about this, right? Okay, we've got 3 streams, merge them, send them, adapt them, and send them, right? We're talking about the correct level of complexity. Okay? If the problem is simple, we should be able to express it in a simple way. Then if the problem is complex, it's okay to express it in a complex way because the problem itself is complex. Okay? But when the problem is simple, as well, let's merge streams, let's have different streams, well, we need to be able to talk about it in the same kind of, same level of complexity. All right? And here, we're talking about streams, and the same way I express the problem, I express it in the code. Okay? Now, let's see if we started. It's starting. Let's see it happening. So it's better to see it running than just, okay. So that's what we got. Okay, 3 illustrations of what's happening, and I can like, so this is the memory I got, okay, and what's interesting here, you can see, if play is taking only 3 megabytes of heap to start itself, which is quite good, okay. Now basically what I'm supposed to be doing here is to use Apache Bench to hit this URL /load. But the problem is my Apache Bench is broken for some reason. Actually, on all Mac OS 10 is broken on Lion, I guess, and I guess they didn't fix it. Let me try anyway. I'm not sure it will work. Yeah. Let me try again. Okay, it just seems to be sending. See the cursor, but we're not getting anything in the request per second. So, yeah, basically this is the problem I talked about. Anyway, okay, but that's you can test it on your own machine if you got Apache Bench working. And on the other machine I had it working. On this one I forgot to set it up, and the same thing happened yesterday. Okay, so now basically what we got here is just we got 3 streams, we composed them together, we actually combined them and we send them. But that's even more, it could be even more interesting. I can get like a dictionary of streams, okay? A map of streams, and I get the user to tell me which stream he's interested in, and I compose them on the fly, like a la carte kind of stream, right? And that's exactly what we did. You have this project you probably saw already, is the type-safe console. So type-safe console is a console for monitoring any ACA system. It will be monitoring what's happening in the ACA system in real time. Okay, so if we go there, we see our app, we go into our app, and we'll see the nodes. We can see when they come. If I have internet, I have internet. Here's coming. We can see the system and the node and another node, right? We have 2 nodes in the system. They got dispatchers and so on. So this is basically, well, first it's built on top of Play. It uses this exact mechanism. And what's interesting about it, okay, that these streams are composed depending on the demand of the user, which means if you look on the query here, we're saying like on the left, I want all the nodes, and on the right, I want all the dispatchers. Okay, that's in the URL up there. Now, if I could choose to have the stream of node 1 on the left side, which means here, and dispatchers on the right side, and if I hit it, I will only get the node 1 on the left side, and I will continue having dispatchers on the right side whenever it happens. All right? So that's a composable kind of streams. I got a dictionary of streams somewhere, okay? And whatever the need of the user, I will go compose these streams, interleave them, and send them, okay? And again, I'm talking about the right programming model. That's why I can express these things in a very simple way. And actually, the implementation behind the scene is exactly the implementation that I showed in the live monitoring stuff on the sample, okay? Actually, I did the sample just after implementing this system. I thought like, wow, this is really interesting. Let's put it into the sample. And that was very easy, right? It was very easy to implement this stuff because you got the programming model right. That's why you really absolutely need a programming model for expressing these things. And actually, it could be even more interesting. So let me take another use case. Well, first, I would like to show another example here. So there is this service. So there's Guilt, which you probably already know, but I have this kind of live stream, okay, that's also based on built on top of Play 2, And that's a live stream, real-time live stream of what's being purchased right now on the server, on their app, on their service, right? And we'll keep pushing these events, these messages each time something is bought, and you can actually filter it, right? Woman, men, or whatever you want, and then you get these streams of data, okay? And that's using WebSockets, and based on this same paradigm, okay? Same programming model. Now another use case, we have this open source chess game, okay, service. It's open source. You can find the source somewhere. You can look into it, how they implement it. And actually, it's not only one game, but you have a lot of, like, some peers connected. You have, like, right now you have 232 peers connected playing chess and playing games. And you can also yourself choose to play. And now I'm playing, okay? And I will disappoint the other party because I will stop. Okay? Okay, goodbye. Now, I can see all the games that are running right now, okay? And I can see them happening in real time. Now I see modification in real time, okay? That's also, he takes all these streams and combines them and sends them into the client, right? When we talk about the right level of abstraction, then you get to be able to do all these things in a simple manner, because the problem is simple, right? I got all these games. Well, let's stream all the games to one person. Okay, of course, you can do it, right? Okay, that's just a few examples of how can you use all of that. And actually, Guild, even in their page, they use streams for prices changes and some other stuff that are changing all the time, but it's less visible than it is on the live side of it. Okay, now, oh, I still have this game. Okay, let's move. And, sorry. I was going to lose anyway. So. Okay. Now, I can do even better. So if I go to this example, so I got this application, this sample that I got, where it represents some business that has some operations that are going on. Okay, let's look into the code. Maybe it's the easiest way to explain it. So I forget the name, streams demo, yeah, app, controllers, application, okay? No, actually I don't want to go there, I want to go into models. So this is my model. And my model consists of, so first I got the trait. This is the type of, it's event. I got events in my system, okay? That's abstract. And then I got two types of events. One of them is operation, and the other is system status, okay? An operation have an amount, okay, the amount of the operation, and it has a level. It can be private or public, okay? Level can be public or private, and the amount could be something, whatever, random value, okay? And I got this system status that is basically noise that the system will be generating, okay? Now, what I will do is I will generate, actually, for the purpose of this sample, two random streams, completely random, that happening like with the same mechanism of having like promised timeouts. So it's just generating at random times, random values, and random booleans for all what we need to define an operation, right? It's a random stream of values. You could imagine that this is coming from the data store, from the network, from whatever we want, okay? But here we're just generating random values. And I got some random noise also generated. So I got two streams of events. So the type of messages in this stream are events, okay? Now what I do is I interleave these two streams, okay? So there is also another way of writing interleave. If you want, if you prefer operators, then you can write it this way. And basically what it means, sometimes operators are better for if you want to structure your code in something like, you know, do this, then do this, then do this, then do that. Sometimes methods are better. You choose whatever it makes sense to you. This means like you got here two streams that is converting to one stream. This is what the meaning of the operator, okay? But that doesn't matter. Okay, so now I got my events, that is a combination of operations together with noise. That we already say it, right? It's exactly what we did in the other sample. Now, and that's all we got in here, in the models. Now let's see in the application part, what do I do with models? Now something I want, so that was the model, okay, something generic. For all my business, I got these streams, they can be picked up by any service, okay? Now at the client, at the app level, so that's a particular application, very specific application I want to do. And what I want to do with this application, there are two basic important functionalities. One of them is that I tend to have different kinds of users. I have managers and I have public users. So for normal users, they should not be seeing any a private operation, okay, and no system status. Okay, all of these should not be shown to normal users, whereas managers can see everything. Okay, so that's kind of a security kind of concern I want to introduce in my app, right? And I got these streams of things. How can I introduce that? So basically, I got this feed action in here, okay, that has, so the action will get, in some way, will get the role of the user, the lower bound and the higher one we will talk about later. And I introduced this secure thing. Secure is an adapter that can apply it to any stream that has events, and I produce a stream that has events too, okay? So that's just an adapter, okay? Now, how can I use this adapter? Well, it's simply a collect. So if you use the list API in Scala, you are probably familiar with collect. Collect actually will be filtering, will be collecting just certain parts of messages that are happening there. And basically what we're saying here is that this adapter will be collecting, well, system status if the role is manager. Then that's okay, you can pass it on. If it's an operation that is private, then I want absolutely the role to be manager, and then I can pass it on. And if it's a public operation, whatever the role is, then I can pass it away, pass it on. Okay? So I'm saying what I'm going to accept. So this is actually introducing the security concern into my thing. It's an adapter that will only show the appropriate messages for the connected role of users. I just introduced security concern, okay, as a collect adapter. Now I have another functionality of my app is that I want the user to be able to provide some kind of bounds for bounds of interest for operations that he's interested in. So the typical user will be saying like, okay, I'm only interested in operations between 500 and 1,000 and not anything else. So that's a different, complete different functionality I have in my app. And I call it inbounds. It's also an adapter, okay, from event to event. It's not changing the type of events, type of messages, okay, and you will be collecting from operations, okay. If we have an amount, then amount should be higher than the lower bound and lower than the higher bound, and I pass it on. Is a system status, and I don't care. I just pass it on, okay. So that's a different concern, and we see here that I don't care at all about security. I just say, okay, my concern here is to be inbounds. The other is saying like what I care about is being secure, right? And having the right messages passed, the events passed. Now I have a third kind of adapter here that is basically transferring everything into JSON, right? So I'm taking an event here. It's an adapter from event to GS value, right? So I'm taking I can take a stream of events and I can produce a stream of GS values here. And actually I'm just taking every event and I'm producing a JSON out of it. So I'm using the JSON API to make a JSON out of my event, okay? And actually I'm typing it, I'm saying like, okay, the JSON has an attribute that is type that will be having an operation and so on, okay? All right, so I get these three adapters. Now what I can do with these adapters, and these adapters can be in different places in the application, different files, different projects, whatever I want, right? They're different concerns, and they're not, I mean, you can have them in different places, right? As the streams happen to be in different places, different files, different projects, okay? Now, in this app, I want to use them. That's why I combine these adapters. So I compose the adapters. I say, okay, I got the secure, I want to compose it with inbound, and compose all with as JSON. And now I got one adapter. Now, what is this, the type of this adapter? Who can answer this question? Let's see if there's someone follows here. Okay, I can provide some help. the adapter is from event to JS value, right? Okay, and then I take this final adapter. Okay, I take the events I have. Okay, the events that I got in the models place, and I pass them through this adapter and then through the event source protocol. Okay, now we got it right, and we started streaming it. Okay, let's see it in action. Should be here. Okay, I don't know, where am I? Where am I? Okay, not here. Okay, here. Okay, so it should be, what should it be? Streams demo. Okay. Starting my app. Okay. So we got it right. Okay, we got it compiling. Okay, so I'm starting to have the operations. Okay, so as I'm connected as a public user, I'm only getting like the public events, only operations that are public. Now, if I go and connect as a manager, wow, very secure way. And now I can see all the operations, right? Private, system status, and everything. And then, of course, I can apply my filter, saying like I'm only interested in between 500 and 1,000, and that's all what I get. All right? So that's really represents kind of a real world kind of use of streams, where I need to manipulate streams. I need to reason about them, filter them, collect them, merge them. You know, talking about the right thing. Like streams are first-class citizen in my programming model, right? So, any questions so far? Yep.
Well, I have about 5, but I can save it to the end.
Yeah, give me one of them, and then
okay.
we again.
Well, the big one is so much of what you're going over isn't specific. So much of what you're going over is not specific to HTTP. You're essentially providing really good I/O support to this HTTP. So having iteratees and enumeratees that make sense, that are usable in Scala, and since you're building everything on top of Neti, is there any plan to support other protocols, raw TCP, UDP, things like that?
So actually, so so for play, it doesn't make sense, right? Because HTTP, it's a web. Sorry, no, it's a web server. So I can support. I support web. We support websockets, comet, and all of that. But of course, I mean, if you got some API, if you want something like to do in your app, in your web app, you want to support some other code that goes through TCP, of course you can do that. And we in some hack days we do at the Next City, we did some communication with other things where we integrate a stream, this kind of stream. Okay, and I got an example here that is, for instance, communicating with Mongo, which is not HTTP. And pulling, so the example I showed earlier with photos is actually talking to Mongo, but it's not over HTTP, it's over TCP, and it's happening with these streams. Now, will I make something generic to support any protocol? For now, timing is not at all the focus, but if it makes sense for someone, I mean, it's an open source project, you can start an effort and we can maybe try to integrate it if it makes sense for us, right? But again, the MongoDB thing is implemented by the MongoDB driver, the reactive Mongo, and he implemented this kind of stream that can pull all of these things and push them also back to Mongo. And actually, I got an example I can show, right, and I was willing anyway to show it. So it's like reactive something, Mongo tailable cursor, and okay, let's start it. Not the right play. So Where was it? Okay. Wow, very small memory. Play, run, is Mongo running? Or Mongo there? Okay. So basically here what we got is that in MongoDB you have something called tailable capped collections. So capped collections are capped collections, and they kind of offer you the opportunity to maintain a cursor into that collection and to keep pulling from it for new messages. Okay, it never closes. So you have this open socket and you can keep getting new stuff out of this collection. So whenever someone inserts, you can keep getting that without inserting new connections to Mongo. And actually what we do is that we integrate an enumerator into that process, okay? And then we stream it to the client, right? So what I got here is this app where I can say something like here, I'm not writing right, okay. Puerto Rico, actually it was, and I'm getting the stream back in real time, right, from Mongo. Okay, so it's basically a WebSocket application where I'm pushing messages into the WebSocket, they go directly into Mongo, and I'm pulling back from it. Okay, and the model is the same because Mongo, this reactive Mongo, this driver provides an enumerator from the collection. You can connect to a collection and say like, give me the enumerator out of this, and I'm going to give it to that to play, to stream it to the client. Okay, and it's basically the same stuff that we did with the images upload. Okay, so yes, it makes sense. It's a very good way of doing I/O. I mean, the whole model. I'm not saying like iteratees are particularly interesting. The model of talking about streams in this way is interesting. Now there are different implementation of this kind of thing, but they all share this kind of semantics of let's talk about the streams in a good way, in the right level, and let's provide this kind of reactive kind of way, non-blocking and so on. Okay. Questions?
For 2.10, do you guys plan to migrate the futures and promises to SID 14? Or are you worried about backwards compatibility with the APIs?
Can anyone answer this question? What's the answer? Mike, you know it already. Mike, I told you already.
Backwards compatibility is for pussies.
No.
Awesome.
It's already, yeah, it's already there. So yeah, oh, right. So it's already there. And it's already in master. It has been like quite some time. We do use, all the samples I showed actually, they have futures, like Scala concurrent futures. Okay? And we replace everything with Scala concurrent futures. And also the iteratee API is using the Scala concurrent futures. So we migrate everything. And it was quite a relief for me. I mean, you know, having your own implementation of futures, it's kind of fun like to implement it, but it's not fun to maintain it. So it's very good that someone did it in Scala so that we can be relieved from that part. Any other question? Okay. The good thing here is that they don't kick us out, as what happened yesterday. So, wow, some energy. What is, okay. So now what we saw is that, I'm starting to make some echo for some reason. Okay. So now we got a way of thinking about streams in a reactive way. We can adapt them, compose them. There's a whole API actually that does exist for iteratees that we implemented, where you can even buffer, you can do a lot of things. So one of the things that you could be doing, and I sent some examples, some samples, is that you get some, let's say, someone uploading a file that happens to be in a CSV kind of format, and you can start reading it progressively, do something with it without loading the whole file, right? So it's like you can understand line by line and load them into the structure, all of that, all the progressive kind of treatment of events, you can do it easily with iteratees. But that's not all, because you can even use iteratees in another completely different domain. Now, if you have, let's imagine you have a lot of computation to do, right? Let's say like you spread hundreds of futures, ACA futures or actors, and then you have like, let's say hundreds of futures that will be eventually sending some result. Now, all these futures, so each of these each future of these can be imagined as a stream of one value that's happening reactively at some point. Now, if I imagine each as a stream of one value, this only means that I can combine these, interleave these streams into one stream. So, which means that I can use iteratees and the iteratee model as a MapReduce kind of thing, right? Where I can spawn a lot of things and then combine them in one stream and say like, okay, client, here you got the result. Which is really interesting, right? Like you can imagine like also calling a lot of web services, combining these and send them to the client. And that's, we have some client already use this kind of model where for instance, like the service for booking flights, that will talk to a lot of services and then produce these, merge these streams and say like, okay, we want at least 10 results, or we want only 10 results, which means like you'll get 10 results and then you stop. But the 10 results is the first 10 results you get. So it's kind of MapReduce kind of thing, but in a streamed way. So you can even use them that way, right? And I got a sample there, but what I would like to show actually is not this, but rather another sample. So now we saw that the stream can be coming from a data store. It can be produced by like myself using polling. It can be even imperative. Someone can be pushing into some point to produce a stream. All of that is possible. We got even wrappers around input and output streams for legacy APIs. All of these you have it already, right? But there's another example where, for instance, we have Twitter, and I mentioned Twitter several times. They have this stream API. Okay, this stream API is basically you make a web call, okay, and you have this open socket with this API. You do a search, for instance, and you have it open all the time. It will be sending messages as they happen. So if I make it's kind of, let's say I'm searching something and I'm getting this live stream, and they're pushing tweets as they happen to me that match this kind of search. So I can integrate that into Play, right? If I can transfer this web service call into its stream, into an enumerator, then I can plug it into Play and stream it through the wire, right? So let's see let's see this example. Okay, Play 2, samples, in progress, Twitter stream. Okay. Okay. And I will open it also with my editor. No. Saving it first. Okay. So I get in workspace. I forget. Okay. Play framework. Play. No. And it was in work in progress, right? And then Twitter, whatever, app, controllers, and application. Okay. So here, basically, what I'm doing is, well, there's some, of course, to be able to do that with the Twitter API, you have to do some authentication. That's why there's the few lines before, just saying, okay, these are the tokens, and this is how I do authentication with Twitter. And that's not our scope now. But what I'm doing, actually, other than that, is that I'm doing this WS call to this kind of API and sending the search term inside the URL, right? And then I'm signing and I'm getting the result, right? It's the same thing, and I'm getting this result and I'm streaming it with Play. Okay, that's all what I'm doing. Very simple. We're talking about simple things. We continue being simple. Okay. Now let's see when I run it, what does that give? So if I go, no, sorry, localhost. Okay, so I got this search. Now I would like to have like some search of live tweets that are happening now on some topic. And to illustrate how impressive this is, I would choose rather a term that is used a lot. Now, what is used a lot nowadays? Well, there's a timely thing that is used all the time. LOL. Sorry? LOL. Visually. So it's really used a lot. So this is an example, and I can do. Okay, I will show it even more. So sorry for stopping. Okay, so what I can do actually is search for a term. So each time I search for Play framework, and like I spam everyone that follows me on Twitter with that. It's here, your mic. So I would let me like, what should I use as okay. No, not this. So I will try to tweet something, okay? So let's say I'm searching for a Play framework. Or let's say real-time web. No, Play framework is good. Play framework. I'm searching for Play framework. Okay? Now what I'm going to do is go in here and tweet about that fact. Doing some demos of real-time web at cloud. Okay? And Scala based, right? Okay, now I will go ahead and, oh, I didn't say Play, right?
It's a pretty good tool. We can figure that out.
I thought it will complete it itself. Okay, tweets.
Wow.
That's really real time. Now you can try it yourself. Yes, question.
What if you wanted to get the top 10, or, like, if you had a leaderboard for people doing a game or something, but you want to display a website with the top 10 of those
let's say like
results.
Yeah, I mean, you can, then you should implement the logic to do that, right? You need to get the live, so you should get the live stream and to do your own algorithm for this, determining what is the top 10, right? So I can get all the tweets as a live stream and maintain a dictionary in somewhere where I get like, in some way, give score and get the top 10, right? And you can implement it very easily. So
you would do that on the server, or would you do it?
Whatever makes sense, but if it's if it's something that I need some other calls to be able to determine what the score is, I better implement it in the server. If it's something very simple, I can implement it very easily at the client side, right? So it depends what I'm going to do. Another question.
Hey, so suppose if I wanted to build a native mobile application that is tapping into the Play framework as well, and I obviously have a web application as well. How feasible is this given the current?
With streams, you mean? Do you mean with streams?
Oh, yeah.
So, okay. Well, it's very strange. Yesterday I got exactly the same question asking about the native. Yeah, it wasn't you. So basically, if, for instance, you're using something like WebSocket or any other socket, then you need to have that into your native app. So you're saying like maybe you're using iOS, then if you have an API where you can open a socket and receive messages, then you can implement the protocol yourself. And it's not very hard to implement. Well, WebSocket is a bit complex. I mean, it's more sophisticated, but something like comet or server sent event, you will be able to implement it very easily at the client side. And now if you get to implement it, then you can do that very easily, right? You can open a socket to play, okay? You don't care if it's HTTP or not. You just go ahead and parse it in some way and get the result. So it's feasible. Now, did someone do it, integrate with WebSockets or with server sent and other protocols? There should be someone that did it already. But if it's not, then you can do it and open source it. Why not? But yeah, it should be feasible. I mean, nothing impossible, right? It's very, just understand the protocol, parse it, and use it. Okay?
Thanks.
Other questions? Okay. Continue? You're hitting my limit now. No, not yet, but I'm supposed to be sleeping now. What time is it in, like, I say Paris time? Wow, I'm waking up.
It's time for a croissant. Where we gotta go?
So, okay, what other stuff I can show? So again, like in the samples, you get like a different kind of apps. One of them is a web chat. Well, web chat is a basic thing you could do with WebSocket, and it basically is just a stream and a consumer, right? And each will be doing something about it. We have this app that is doing exactly this. Yeah, I thought I'm in another machine. So it should be inside play, 2.0, samples, Scala, maybe comet chat or something. No. WebSocket chat. Okay. Again, here we have the same kind of structure, and when okay, so basically we have a chat in the route chat action that have a username. It will produce a WebSocket, and it will like join the chat room. Now let's see what the chat room is. Chat room is in models. So basically, here we have. So we use actors. It was one of the ways like to do it. You can do it in different ways, but one of the ways like to have an actor that will be receiving these messages and sending them to a stream that is then shared by a lot of sockets. Okay. So you want also to be able to broadcast, kind of to have one stream that can be broadcasting to a lot of users, and that's basically what the chat room will be doing, right? Because you got a lot of people connected, they send in messages, all these messages go to one stream that is then broadcasted to everyone, right? And that's basically what this app is doing. What's interesting here is that I can mix the same kind of stream with a robot stream, okay? So I got a robot stream, I got the real stream, and I merge them, and I can push them to the client in the same way of so in a modular way of talking about streams. And then, of course, in the client side, I will get this stream, and I will push it as a WebSocket. So I'm not sure if, so I updated all the samples, but I don't know if this one I updated for master. Let's try to see if it works. If it doesn't, I could either fix it right now or maybe later, I don't know. So, where is it? Was supposed to be here, right? Yeah, WebSocket chat, thank you. I didn't see it. I guess it won't compile because we changed quite a bit. Yeah. Oh. Yeah, it's going to break in the next step.
Yeah, well,
It's the compilation that wouldn't work, I guess.
that's the compilation test.
A lot of warning for now. A lot of warnings. Wow. Okay. Let's try it out. Okay, I got robot talking to me. And okay, someone else. Yeah, I see like Sadek here. Yeah, kind of works. Okay. So anyway, I guess the best is like go into play, look at these samples, play with them. You got like different kind of things you can do, and you can play with them and experiment with the whole concept. Now let me retake my slides if that matters at all. Oh, did someone talk to me? No. Okay. Oh, that's not good. Each time I have to ruin the whole thing. Okay.
Keep the red pill on down.
So actually what I wanted to show in this presentation is like we got really a powerful reactive architecture already, okay, execution architecture that's in place. We get features that can help us compose, remember, compose to do the asynchronous stuff without all the pain of doing asynchronous stuff, because we want to get advantage of being non-blocking, reactive, and all of that. And we got the tools to be able to do that. Features and also iteratees that helps us to do streams in a reactive, completely non-blocking way. And that's really essential to what they're in play. I guess today, if we talk about real-time web and modern web, we need to have the tools. We should not have only so access to the functionality, which means like on message or channel.push, but we need to have a whole paradigm that is capable of, that allows us to talk about the right vocabulary, the right concepts in our model. And that's, I hope I could show enough examples to show like how important that is in modern web apps and real-time web apps. You can check out the website, okay, playframework.org. We have a very, very active mailing list. Now you can ask me how many people are there. I won't be able to tell you because each time I forget, I have very short memory. But you can check out, and we got a lot of people. Each time I tell it, people are saying, oh, wow, that's good. So it should be a lot of people. And this is very random what I'm saying. So, and you can go to GitHub, you can check out what we're doing. Also, we have a lot of forks, a lot of people that are contributing into the project. You have really a good team that is rolling already from the TypeSafe side, and from the Zenexity side also we have a lot of contributors. So get engaged, ask questions at the mailing list. People are really happy to answer in there, really friendly kind of place to ask questions. And yeah, if you want to know more about this reactive Mongo thing, then you can check you know, the repo and the websites. And I guess that's it. I'm very happy to stay as long as you want for your questions. Sorry?
You just woke up.
Yeah. Well, thank you.
Good morning.
Look for Micronautics Research for pragmatic Scala training, architectural design, implementation, and systems integration. Ask about our complimentary introductory presentations on Scala today.